So in our previous class we have discussed about the rank finding matrix, rank finding methods for the matrix. Now we shall discuss about solutions for the system of equations. Here we use the same technique, that is rank finding method, to see whether the system is consistent or inconsistent, and also if consistent, how we can find the solution of system of equations. Now we are considering system of linear equations. Linear equations in the sense the variables occur only once. No product of same variables or product of different variables never occur in the equations. Let us consider a linear equation in three variables x, y, z. It is in the form ax plus by plus cz is equal to d. Ax plus by plus cz is equal to d, where a, b, c, d are numbers. So such a system of equations, that is system means more than one equations, we call it as a system of linear equation. The general form of system of linear equations in n variables or n unknowns x1, x2, xn is written as a11 into x1 plus a12 x2 plus so on. A1n into xn is equal to b1. The second equation is a21 into x1 plus a22 x2 plus and so on. A2n into xn is equal to b2, and there may be such m equations. So such system of equations, such a set of equations is called as m linear equations in n variables or n unknowns. If we write it in the matrix form, we can write it as ax is equal to b, where the big A is called as coefficient matrix, which consists of all the coefficients of x1, x2, xn column wise. That is, the first column is coefficient of x1, second column is the coefficient of x2, and so on in variables. So we write big X is equal to x1, x2, xn as the components of this vector. So here big X is called as the column matrix or column vector, and x1, x2, xn are unknowns whose values to be determined such that the values satisfies the equations. B is called as b1, b2, bm. B is called as the constant matrix. B is called as the constant matrix. You note that when we write it in the matrix form, Ax is equal to B, A is of order m cross n, X is of order n cross 1, and B is of the order m cross 1. So you may note that if m cross n into n cross 1 is the matrix multiplication, then the result will be m cross 1 matrix. So B matrix is of order m cross 1. The set of values x1, x2, xn, the set of values for the unknowns x1, x2, xn, which satisfies the given equations, is called as solution of the equation. I repeat the same sentence. The set of values for the unknowns or the variables x1, x2, xn, which satisfies the equations, which satisfies all the equations in the system of equations, is called as solution of the system of equations. And another one point is, if in the B matrix, in the constant matrix B matrix, if all the Bi's are 0, that is B1 is equal to 0, B2 is equal to 0, and so on, all the Bi's are 0, then the system of equations is called as homogeneous system of equations. Homogeneous of system of equations. In other words, the matrix form can be written as Ax is equal to 0, where 0 denotes the null matrix. null matrix with all values are 0. And in a non-homogeneous system of equations, at least one of the bi's in the constant matrix is non-zero. So at least one of the b1 may be non-zero, or b2 may be 0, or few of the bi's are non-zero. If there are m equations in n variables, then the coefficient matrix A is a rectangular matrix of order m cross n. If there are n equations in n variables, that is, the number of equations is equal to number of variables, then the coefficient matrix A is a square matrix. And if A is invertible, that is, A inverse exists. In the sense, the matrix must be a square matrix and its determinant is non-zero. Then A inverse exists and we call it as invertible matrix. So if A is invertible, then for the system of equations Ax is equal to B, the solution x can be obtained as x is equal to A inverse into B. But when the matrix A is a large matrix, say it consists of more than 3 rows and 3 columns, or the matrix A is a rectangular matrix, then this technique, that is x is equal to inverse of A into B, may not work. In that case, we use another simple technique which will reduce the matrix to row echelon form and solve or find the solution. So to use this technique, we follow three steps. One is, along with the coefficient matrix A, we add one more column of constant matrix B. That is, we consider the matrix A along with one additional column of constant matrix B, and it is called as augmented matrix. Augmented by one extra column of constants. The coefficient matrix A is augmented by one column of constant matrix. It is called as augmented matrix. So we first write the augmented matrix AB. In the second step, reduce the matrix AB to its equivalent row echelon form by using only elementary row transformations. And then we find the rank of both A part and the entire matrix AB part. That is, we count the number of non-zero rows in the matrix A part, that will give you the rank of the matrix A. Then we count the number of non-zero rows in the entire matrix AB, in the whole matrix AB, and that gives you the rank of the entire augmented matrix AB. And if rank of A is equal to rank of AB, then the system has at least one solution, and we say that the system is consistent. The system is consistent means it possesses at least one solution for the system of equations. So if rank of A is equal to rank of the augmented matrix AB, then we say that the system is consistent and has at least one solution. And if rank of A is equal to rank of AB, and this common rank is equal to n, the number of variables, the system has unique solution. That is, the system has only one solution. And if rank of A is equal to rank of AB, but this common rank is less than n, then the system has infinitely many solutions. Here n denotes the number of unknowns. So if rank of A is equal to rank of AB and less than the number of unknowns, then the system has infinitely many solutions. If rank of A is equal to rank of AB and this common number is equals to the number of variables, then definitely the system has only one solution. And if rank of A is not equals to rank of AB, then the system has no solution and it is said to be inconsistent. The system is inconsistent if rank of A is not equals to rank of AB.